Friday Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Aberty Sassi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. This session will provide Tejano password points, and the code will be posted at the chat towards the end of the session. Thank you. So now, at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Without further ado, I'll pass it on to our presenter so that we may begin.
Good morning, everyone, and thank you again for joining us for our Friday Happy Math Hour. Again, if you are here to do the Math 1324 Happy Math Hour, please click on the link that's on your chat. So the rest of you, let's go ahead and get started. So for today's session, our topic is going to be linear and nonlinear systems of equations. Okay, so first, I hope that you all recognize that the word linear, we're going to be dealing with lines and graphs of lines, but maybe the new word that you haven't seen so far is this word systems. Well, all systems is, instead of graphing only one line in our rectangular coordinate system, now we're going to be solving or graphing more than one line on that system. Okay, so that's what systems is. That's what systems is all about. It's just dealing with more than one line. Now, what we're going to be doing also is we're going to be solving these systems, and to solve the system, what you need to know is that what you're solving for is where these, if I was talking or referring to equations of lines, is where the two lines intersect. And what that means is our solution point is going to be an ordered pair that satisfies both of the lines, meaning the x and y value is true for both lines. Yes? Now, a solution set is a set of all ordered pairs that satisfy both equations. And we're going to mostly deal with sets when we're dealing with the nonlinear part. And the nonlinear part means that we're going to be dealing with either a line in a circle or a line in a quadratic, or maybe two quadratics or two circles. So that's what we're going to be solving for, is more than one equation at a time. And the solution is where those equations or graphs intersect. Okay, so let's go ahead and get started. So here, just to go over some stuff, a system can be of a linear equations can have at most one solution, or a nonlinear equation can have at most one or more solutions. Okay, so there are three ways to solving or getting the solutions of systems. And the ways that we're going to cover are substitution, elimination by addition, and graphing. Okay, so again, the solution is where these graphs intersect. Now, if we were to look at, the graphing aspect of it, okay, so the solutions to these graphs, for instance, in this first one, we have two linear equations, and where they intersect at this point here, 2, 0, that is going to be my solution. Okay, now if I look at a nonlinear system, well, in the second example, or in the middle picture here, we're dealing with a graph that has a line and a parabola, right, which comes from our quadratic equation. So in this, we're going to have a solution set. We're going to have two answers for this. So we have 2 points where it satisfies both equations. So on this one here, at the point 0, -1, this x and y value is true both for the line and for the parabola. Also for 2, 1, the point here, 2, 1, the x value for 2, the y value for 1, satisfies or belongs to both the parabola and the line. Okay. And if we look at the last picture here, or the last example, this would be a no solution because we have a line here in a parabola, but this line does not intersect with the parabola. So hence, there is no solution. Okay. Now, let's practice as far as what we're solving for before we get into actually coming up or solving the solutions for the systems. Okay, so we have this example where they give us a system of equations. Now, um, note that to indicate that we're dealing with a system, your homework or book is going to write a squirrely bracket before the equations. So the squirrely bracket means that now I'm dealing with a system of equations, and that these two equations are going to be graphed on one rectangular coordinate system in order for me to find out where they intersect. Okay, but for right now, they're giving us a solution or the possible solution. They're saying for A, is 0, -4 a solution of the system? And for it to be a solution of the system, this x and y value has to be true for both of the equations. Okay, so let's go ahead and find out. So the first thing that I'm going to do is I'm going to get my solution point 0, -4, and I'm going to put it into the first equation here, which is the 2x minus y equals 4. So again, x equals 4, y equals -4. So when I simplify, I see that I get this a statement 4 is equal to 4. This is a true statement. So that tells me that this point 0, -4 does lie on this line. Okay, so but in order for it to be a true solution, it needs to also satisfy the other equation. So I'm going to go ahead and plug 0, -4 to the second equation, which is 8x plus y equals -9. And I'm going to simplify. And if you see here, I get this. -4 is equal to the -9. This is a false statement. This is not true. So even though it was true for the first, but not for the second, this is not a solution for the system because it has to be true for both. Okay, so again, the what you will write on your homework is 0, -4 is not a solution to the system. Okay, so let's look at the second example. What about x is equal to 1/2 and y is equal to -2? Again, I will do the same thing. I'm going to plug in this x value to the first equation, and I see that I get a true statement, 4 equals 4. And I'm going to do it again for this value for the second equation. Replace x with -1/2, y with a -5, and then I see that I get a true statement again. So hence, since I got a true statement for both of the equations, then that means that -1/2 to, -1/2 and -5 is a solution of this system. So you would answer yes. -1/2, -5 is a solution of this system. Okay. All right. So um, that's what we're trying to do. Find a solution. So there's two ways other than graphing, because if you can see, graphing could be unless we have a graphing tool that tells us the actual point where they intersect. Um, it's very difficult to see where two lines intersect, especially if they're not whole numbers, right? So we're going to solve these algebraically. And the two methods that we're going to show you today is one's called the substitution method and the other, the elimination by addition method. So let's start with the substitution method. So I tell my students, okay, if I told you that I wasn't going to come to class today and I'm going to have a substitute, well, what does that mean? Well, that means that somebody else is going to replace me to do the class. This is the same concept that we're going to do to solve systems of equations with a substitution method. And the substitution method works this way. First, you're going to choose an equation. It doesn't matter which one it is. And you're going to solve for one of the variables. Again, it doesn't matter which one. And once I do that, um, in this case, I solve for x. I'm going to get this value here, and I'm going to substitute what that value, what that variable represents to the other equation. So here, I use the equation x plus 4, y equals to 4, and I got x equals 4 minus y. I'm going to replace this x value into the second equation, which is x minus y equals 2. So everywhere I see x, I'm going to plug in this 4 minus y. So we have 4 minus y equals 2. And then I'm going to simplify or solve for the variable, right? So once I solve for y, I see that y equals 1. Now that I have y equals 1, I'm going to use the one in red in order to get my value of x, okay? So here, um, if I put it here where my value x, 4 minus 1 is going to give me a 3. And again, I plugged it in, or the example here was plugged back in into the original equation, but I like to put it into the variable that I solved for. It has less algebra to do, yes? So if you see, this is what's called a substitution method. Okay, so another method that we're going to be using and practicing is called the elimination by addition method. And again, I go by the name, elimination method. That means that I want to eliminate one of the variables. So to do that, first of all, the solution set again for my first one is 3, 1. Yes, this point here is true for both of those equations. Now, for the elimination method, what I'm going to do is first I'm going to choose a variable to eliminate. Again, it doesn't matter which one you want to eliminate, but here's a key um, advice to help you choose one. The way I choose which one to eliminate with, I look to see which variables have opposite signs. Because if I have opposite signs, I know that when I add them together and they're equal values, they're going to eliminate or cancel out or become zero. So that's what I look for if I have two variables that have opposite signs. So um, if you see here, I am going to choose to eliminate y. Why? Because the first equation has a positive y and the second equation has a negative y. And just if I add these two equations, just as the title says, I'm going to eliminate that y variable. So let's go ahead and do this. So I have x plus y equals 4 and x minus y equals 2. So if I just add these two equations together, what happens is that plus y minus y gives me 0. And if I solve for x, I have x equals 3, which is the same answer as I had before. So now that I have x equals 3, I'm just going to replace that into any of the two equations. And I'm going to replace it into the second one here. The first one, 3 plus y equals 4. So I see that my answer is y equals 1. Okay, so again, my solution set for this one is 3, 1. Now, hopefully you learn how to use both, but I have a preference in elimination. I love elimination. It's so nice and clean. All right, but let's go ahead and practice some more. Solve the system equation by using any methods. So I don't know. Let's go ahead and use the substitution method. And the reason why, again, you wanna look at the problems here. In this particular problem, it's kind of set up to do the substitution method because one of the equations is in slope-intercept form, right? And so it's already um, given to you to solve in substitution. They solve for one of the variables, which is y. So what I'm going to do is I'm going to plug in this value, 2x plus 3, into the second equation. Okay, so everywhere I see um, y, I'm going to substitute it with 2x plus 3. So let's go ahead and do this. So we have x plus 2 times 2x plus 3 equals negative 4. So the first thing I need to do is I need to distribute the 2. It's going to give me 4x plus 6. Combine my like terms, x plus 4x is 5x. Move x to the other side by subtracting 6 on both sides. So minus 4 minus 6 is equal to negative 10. Then I'm going to divide by 5 on both sides. So I see that x is equal to negative 2. Once I have that, I'm going to substitute that into any of the equations. It doesn't matter, but again, if I want to make my life easy, I'm going to substitute it into that first equation that it already has the value for y. So when I plug in x equals negative 2 to the first one, 2 times negative 2 is negative 4. Negative 4 plus 3 is a negative 1. So here, again, my back substitution, I get negative 2, negative 1. Okay, so um, Again, if you have any questions, please let me know. If I'm going too fast, please stop me. Okay, let's look at this next equation. Again, just by looking at it, which probably is the more ideal method to use? And hopefully you see, oh, let's go ahead and use our substitution method again because the second equation has been solved for one of the variables, which is y. Okay, so again, I'm going to use the substitution again, and I'm going to get this value, 2x minus 3, and plug it in everywhere I see y to the other equation. Okay, so here, my other equation is 3x minus 2 times 2x minus 3 equals 7. Now I'm going to solve for x. First, I need to distribute the negative 2. So I have negative 2 times 2x is negative 4x. The negative 2 times the negative 3 is a positive 6. Combine my like terms. 3x minus 4x is a negative x. Move the 6 to the other side by subtracting 6 on both sides. I get negative x is equal to 1 multiplied by a negative on both sides. So x is equal to negative 1. Now again, I'm going to do back substitution. I'm going to put that value back into any of the two equations. And again, I'm going to be nice to myself. I'm going to put it into the second equation where I already have it solved for y. So when I do that, I have 2 times the negative 1 is negative 2. Negative 2 minus 3 is a negative 5. So my solution set here is negative 1, negative 5. And again, I'm talking about a set because even though I do have one answer, I'm just giving you all the answers as a set. Okay. All right. So let's see here. Uh, let's try this example now. Solve the system equations using any method. Oh, and this one, why don't we try the elimination method? Okay, so again, just to recall, we want to eliminate one of the variables. Okay, now in this case, again, what I told you as using a key point, I like to pick one of the variables that has opposite signs. And in this case, both of them have opposite signs. So it really doesn't matter which one we choose. So in this case, I'm just going to choose to eliminate my x. Okay, so I look at these two values, 2 and negative 5, or just the values itself, 2 and 5. I know they're opposites, but in order for them to eliminate each other or to cancel out, they would have to have the same value. When I add the opposite signs and with the same value, I should get 0. So I say, what is the least common multiple between 2 and 5? And I see that my least common multiple will be 10. So what I'm going to do is I'm going to multiply the first equation by 5 and the second equation by 2. And when I do that, I'm going to get 10 for x. But keep in mind, one of the big mistakes sometimes we do is that we don't multiply these values to the whole equation. Remember, we have an equation, so we have to balance it. So we got to make sure that we multiply this 5 and 2 to both sides of the corresponding equation. So let me show you an example what I mean. Okay, so for the first one, I'm going to multiply 5 to the whole equation. 2x minus 7y equals 3. So here, 5 times 2 is 10x. 5 times the negative 7 is a negative 35y. But I also have to multiply 5 to that 3 that's on the other side. So 5 times 3 is 15. I'm going to do the same thing for the second equation that I'm multiplying a 2. 2 times a negative 5x is a negative 10x. 2 times 3y is a 6y. And 2 times 7 is 14. So now I have two equations. And what I'm going to do is I'm going to add these two equations together. So here, if you see here, I have 10x minus 10x gives me 0. I eliminated my x. And now I have minus 35y plus 6y is a negative 29y equals to 15 plus 14 is 29. So to solve for y, I'm going to divide by a negative 29 on both sides. And I see that I get a negative 1 for y. So now I'm going to do back substitution. I'm going to pick any value, doesn't matter which one. I mean, any equation, doesn't matter which one. And in this case, I just picked the first one just because it's the first one. So on the first one, everywhere I see y, I'm going to plug in that negative 1. And when we do that, we see that we got an x equals negative 2. So my solution for these two equations, again, is negative 2, negative 1. And again, remember, what we're solving for is where these two lines intersect. This -2 and -1 is true for as a true value for both of these equations. Okay. All right. Making great timing. Let's go ahead and solve this other problem. Okay. So we have 2x minus 5y equals 6 minus 4x plus 10y minus 1. Okay. So we can choose any method. Again, for me, I love the elimination method, so I'm going to use that one. So again, just because I want to practice, and for this particular one, if I see here, both of them have opposite signs, but if I chose to eliminate the y's, I would have to multiply, well, only one to both of them, so it doesn't really matter. So I'm choosing the x, and so I say to myself, what is the least common multiple between 2 and 4? When I see that the least common multiple is 4, so then that means all I have to do is multiply a 2 to the first equation and then add the other equation without doing anything to it. So let's go ahead and do that. Let's multiply a 2 to that first equation. So here we have 2 times 2x is 4x. 2 times a negative 5y is a negative 10y, and 2 times 6 is 12. Okay, so I'm going to add that to my second equation. And when I do this, oh, I get this. It ended up that I eliminated both my x and my y value. Okay, now let me tell you here, I look at this statement. Is 0 equal to negative 11? No, well, this is a false statement. So what this is telling me, when I tried to solve for this equations and I got a false statement, that means that these two lines are what called inconsistent. And what that means is that these two lines never intersect. So that means that there is no solution. So if they're never going to cross, then there's no solution. Now, I don't know if I have an example on this, but if I would have done the same thing and I would have gotten a true statement, let's say that I would have gone negative 11 is equal to negative 11. Well, what that means is that it's the same line, or we have infinite number of solutions, okay? Um, but let's see if we do an example of this. But again, on this particular one, the answer would be no solution because if I were to put these into slope-intercept form, you would see that these two equations have the same slope but different y-intercepts. And that's the definition of parallel lines, meaning these two lines will never intersect. Okay. All right, so let's look at a word problem that deals with systems. Okay, so let's go ahead and let me read this problem out loud really quick. We have the given amounts for annual interest is earned from a total of $9,000 invested in two funds, paying simple interest. And again, this is to review our previous chapter that we dealt with exponential equations and interest. And it says write and solve a system of equations to find the amount of invested at each given rate. So again, we're investing $9,000 into two funds. The two funds have different rates. One has a rate of 2%. The other one has a rate of 6%. Okay. And together, when we add them, the interest that we earned was $9,000. So what we're going to do, we're going to set let A be the invested at interest rate 1, which is 2%, and let's let B be the rate 2, which is the 6% interest. Okay. So what we want to do is we have this. If I'm saying that A and B are the investments, the A plus B should give me the total, which is the $9,000 that we invested total. But how do we get the total investment? Well, it's the interest rate times the amount of A plus the interest of B. And when I add those together, this should give me my annual interest, which is 380. So we see here, we have a system that we can solve. What we want to find out is we want to solve for this A and B. So what I'm going to do before I start solving it, I don't want to deal with decimal additions. So what I'm going to do is I'm going to multiply the second equation by 100. And again, I'm going to multiply it to the whole equation. I want to make sure I don't unbalance the equation. So 100 times 0.02 gives me 2a, 100 times 0.06 gives me 6b, and 100 times 380 gives me 38,000. Yes? All right, now that I have these two equations, which has nice numbers, let's go ahead and use the elimination method to get rid of one of these variables. So what I'm going to do is I'm going to multiply the first equation by a -2 to eliminate my a. Okay, so let me go ahead and do that. So if I multiply a -2 to equation a, I have -2a minus 2b is equal to -1800. I'm going to add it to the second equation. So -2a plus 2a got eliminated, or is 0. We have minus 2b plus 6b is 4b, and -18,000 plus 38,000 is 20,000. I'm going to divide by 4 on both sides, so I have b is equal to 5,000. So what this is telling me that I invested $5,000 out of my $9,000. I invested $5,000 into investment B. Now, to get the value of how much I invested in investment A, well, that's hopefully easy to do. I'm going to do a back substitution to that first equation. So that first equation says A plus B equals 9,000. I know that B now is 5,000. To solve for A, I'm going to subtract 5,000 on both sides, which is going to give me the 4,000. Okay. So again, this is one way, an example of using real world applications to and systems to solve. Okay. All right. Now let's go to some more fun stuff with science and math. Now let's look at the nonlinear part. And again, as I mentioned to you, the nonlinear part means that now I'm going to be dealing with maybe not just lines, but a line in a parabola, or a line in or and something else, or maybe two parabolas, or maybe even circles. Okay, so again, these are examples. The first one is a linear system because both of them are lines. The fact that one of them is not a line, that makes this a nonlinear system. And same thing with this last one, right? All right, so let's look at solving this system, and we can use any method that we want. Now, if you notice here on the second one, because my exponent for the x is a 1, I know that this is a line. But for the first equation here, my exponent for the x is a 2. So that means that that first equation, I'm dealing with a quadratic. And what is the graph of quadratic? Well, this is a parabola, right? So now we're going to solve this. So um, let's go ahead and use we can use any system we want, but let's go ahead and use the elimination method since they didn't solve for any variable. And also, I'm just looking at this. If I add these two together without doing anything, I'm going to eliminate my y's because I have the same value for y, and then they're both opposite signs. Yes? So let's go ahead and add them together by using the elimination method. And when I add them together, I see that my y's got eliminated. So I end up with a x squared plus 4x equals 0. So again, to solve for this, what I can do is I can use my quadratic equation to solve for uh, the zeros, or I can factor it, and that's what I would rather do, is factor, make it easier. So first I I factor out the greatest common factor, which is an x. So that means that a value that will give me 0 here is 0. And the x plus 4, what value can I put here for x that would give me 0? Well, that would be a -4. So here I have two values for x, okay, a 0 and a 4. So what I'm going to do is I'm going to do back substitution, but I'm going to use it, I'm going to do it for both of these values. So let's start with the x one. If I plug in 0 for, and again, I can pick any equation. I picked the second equation. I'm going to plug in 0 for x for that second equation. So 4 times 0 plus y equals 0. And when I solve, I get that y equals 0. So um, let's do the same thing for -4. When I plug in 4 to that second equation, 4 times -4 is a -16, so that y equals 16. So on this particular problem, I have a solution set that has two answers inside, okay? So one of the solutions is 0, 0, and my other solution is negative 416. Okay, and let me see, uh, well, I didn't graph it, but if I would graph it, you would see that this line crosses the parabola at these points, okay, at the origin and at another point. All right, how about this one? Let's go ahead and do this one. Um, if we see here, now our first one is a line, and our second one is another parabola. It's a quadratic equation. So let's go ahead and use the elimination method again. And I don't have to, well, if I want to eliminate the y's, okay, or the x's, what I'm going to do is, oh, no, let's see here. We are doing, yeah, we're going to multiply first my equation by a -1 to eliminate my y's. Sorry, I fixed it. The previous slide said x and now it's y. Now it's correct. All right, so I'm going to multiply a -1 to my first equation. That way I can have a positive, and when I add them together, I can eliminate my y's. All right, so when I do that, a -1 to the first equation is going to give me a negative x. A -1 times a negative y gives me a positive y, and the -1 times the -5 gives me a positive 5. So now I'm going to add these two equations. X plus y equals -5 with the x squared minus y equals -6. So here, x plus x squared is just the x plus x squared. They don't combine. They're not like terms. But the plus y minus y becomes 0. They got eliminated. All right, how about -5 minus 6? That gives me a -11. Okay, so again, I'm left with a quadratic again, so I'm going to move the -11 to the other side so I can solve it, right? So I have x squared plus x plus 11. So again, I can use any methods that I know how to solve. In this one, since I see that I can't factor it, let's just go ahead and use a quadratic equation. So when I apply my quadratic equation, that's the reason why I couldn't factor it, because if you see here under the radical, I have a -33. And that means that's going to produce an imaginary number, but we are looking for true solutions for these. So hence, this would give me an error that there's no true answers or real answers. So then the answer for this one is no solutions, because I have an inconsistent system. And what does this mean? That this means that this line and this parabola are not intersecting at any point. Okay. All right. Let's look at this one now. How about solving this system? We have x squared plus y squared equals 25, and we have 3x squared minus 16y equals 0. So hopefully with the examples here, you see that the second equation is another quadratic. But what about this first one? We have a square both on the x and on the y. So what this is telling me is that this first equation is a circle. Okay, now it's a nice circle because it doesn't have a shift left or right. This means that the circle it has a center at the origin. Here, the 25 can be referenced to our radius. Okay, so I know that my radius for this circle is 5. Okay, but let's go ahead and solve, and we're going to use any system. Now, this particular one, I think the best way to solve it is by using the substitution method or the elimination method. So let's go ahead and just do that. Let's go ahead and do the elimination method. So what I'm going to do is I'm going to multiply both sides by -3. Okay, I mean, the first equation by -3, excuse me. So let's go ahead and do that. I'm going to multiply -3 to the x squared plus y squared equals 25. And again, I'm going to multiply to both sides. My mind is going faster than my lips. All right, so we have -3 times x squared is a -3x squared. -3 times y squared is a -3y squared. And a -3 times a positive 25 gives me a -75. So I'm going to go ahead and add those two together. Equation 1, my new equation 1 with equation 2. And when I do this, -3x squared plus 3x squared becomes 0, or again, got eliminated. I like to say it. And then now I'm going to add -3y squared with minus 16y. They're not like terms, so my answer is just -3y squared minus 16y. And minus 75 plus 0 is a minus 75. Okay, so I have another quadratic equation. Um, and hopefully you see that this quadratic, um, it has the y-axis as its axis of symmetry, not the x-axis. Yes, so here we're going to solve for our quadratic, and when we use the quadratic equation, we end up with two solutions. We have y equals negative 25 over 3 and y equals 3. Okay, so again, I'm going to do back substitution. I'm going to replace both of those values to to one of the two equations. It doesn't matter. In this case, I'm just picking the first one. So I'm going to start with the 3, which is the easier number. So here, x squared plus y squared is 3 squared is equal to 25. 3 squared is equal to 9. Subtract 9 on both sides. 25 minus 9 is 16. Take the square root of both sides, and I end up with x equals plus or minus 4. Okay, so here I have two answers, right? I have when x is equal to a positive 4, my y value is 3. When x is equal to a negative 4, my y value is 3. Okay, but I solve for both of these. These are my solutions because if I use the other value that they gave me, the negative 25 over 3, okay, I'm going to see that I'm going to get an imaginary number or no real solutions. So my only solutions are these, but it makes sense, right? If I have a circle, I'm only going to have, and it's being intersected by a line, I should only have at most just two answers, not three. So these are my answers. The line is crossing the circle at 4, 3 and negative 4, 3. Okay. All right, so again, my solution set are these 2 points. Again, and you're giving, be careful when you're giving your answers on the computer. Um, you want to give ordered pairs, okay? All right, let's go ahead and solve this one. This one looks a little bit awkward here because the first one is linear, but what about the first one? Okay, so here we have an x and y that are being multiplied to each other. So on this one, I think it's going to be easier to solve using our substitution method. So what I'm going to do, I'm going to take this first equation, xy minus 1 equals 0, and I'm going to solve for x for this one. So when I do that, x is equal to 1 over y. And what I'm going to do is I'm going to replace this x value to the other equation everywhere I see x. Okay, so I'm going to go ahead and have 3 times 1 over y minus 6y plus 17 equals 0. Yes? Okay, so let's go ahead and simplify. So 3 times 1 is just 3 over y minus 6y plus 17 equals 0. Okay. I want to get rid of the fraction. So what I'm gonna do is I'm gonna multiply the entire equation by y. So when I multiply y times 3 over y, I just get 3. When I multiply y times a minus 6y, I'm gonna get minus 6y squared. When I multiply y times 17, that's going to give me 17y. And when I multiply y times 0, that gives me 0. So you see here, to solve for y, this is a much nicer equation to solve. And it shows that I have another quadratic. But again, this is a quadratic where the axis of symmetry is the y-axis. Yes, I'm sorry, the x-axis. So let's go ahead and solve. Let's go ahead and apply our quadratic equation again. Here, just to review our quadratic equation, I'm just using it lightly, but because I hope that by now you guys are all experts in quadratic equations and solving quadratics. But here, the equation is minus b plus or minus b squared minus 4ac all over 2a. Yes? So here in my problem, a is negative 6, b is 17, c is 3. And that's what I'm replacing here. So when I do my my substituting and simplifying, I'm going to get two answers again. Okay, so when um, when this value here that I'm adding from the quadratic, or excuse me, from the square root is a positive and the negative, right? So when I do this, I have two answers. I have a negative 1 over 6 and I have a positive 3. So what I'm going to do now is I'm going to do backward substitution. And when I use the first value, negative 1 over 6, I'm going to plug it into that first equation. So we have x times negative 1 over 6 minus 1. The first thing I'm going to do is I'm going to add 1 on both sides, and it's going to give me a negative x over 6 equals to 1. And then I'm going to multiply by a negative 6 on both sides. So when I do this, I have x is equal to negative 6. That's one of my um, solutions. So then I'm going to do it again. I'm going to use now the value of 3 for the y. Same equation, the first equation. So I have x times 3 minus 1 equals 0. So it's a little bit easier to solve. I'm going to add 1 on both sides. It's going to give me 3x is equal to 1. Then I'm going to divide by 3 on both sides. So x is equal to 1/3. Okay. So my solution set here is when x is equal to negative 6, that was the y value of negative 1 over 6. And when x is equal to 1/3, that gave me the y value of 3. Okay. Now, just let me go back a little bit, and I wanted some white space. And since I have some time, and what I want you to see is more or less what's going on here. So you just grab visually, because some of us are visuals, right? Visuals. Um, we see that we had a parabola like this, right? Our and when I this is our y-axis, this is our x-axis, and when I set that my parabola here, because I knew that my y was squared, I knew that my axis of symmetry was the x-axis here. This is my axis of symmetry that separated my parabola. And again, the other one was a line, right? Um, and I'm just drawing it. I'm not sure if this is it, but what this is happening, what we're seeing here, if I change the colors, uh, where are my colors? Oh, well, anyway, so this is what we're solving for. Our solution set is where this line intersected this parabola, where we got those answers. Again, solving systems of equations is where the two graphs intersect each other, and it gives us an ordered pair, the solution that both satisfies both graphs, and in this case, both the parabola and the line. Okay, and again, like the solution for this one was these. So I did finish a little bit early. Does anybody have any questions? Okay, well, again, thank you for joining us today. If you just barely joined us and you're logged on right now, you can download a copy of this presentation just on your upper right-hand corner, the little symbol that has a little box with the arrow pointing down. If you click on it, you'll be able to download my presentation. Um, Again, thank you for joining us, and I'll pass it now on to our collaborators. Thank you so much. Have a great weekend, guys.
Thank you, Mr. Carrizales, for this amazing presentation. For the next week, remember, for Math 1314 is the basic matrix operation and using matrix operations. And for Math 1324 is sets. And so have a great weekend and see you the next session. Thank you everyone to be here. And if you have any questions, please let us know to any question that you have. Thank you. Bye bye.